So we're given a box of supplies that weighs 1,200 pounds, is suspended by these two cables attached to the ceiling. What is the tension in the two cables? And it says, note, an object is at static equilibrium when an object is at rest, and the sum of all forces acting upon the object is 0. So what I probably would do first is redraw this. And I would draw it in this sense. So this force here, my cable, let's call it force 2, and it's going to be the 45 degrees. And then this force in my cable, let's call that force 1, is going to be 30 degrees. And you'll see the reason why I redrew that is I really need this angle, okay? So if that's 30 degrees and this line's 180, so that would be 150 degrees. And then finally the box, okay, and we can call this F3. All right, so let's see if I can get all this stuff written out. So I want to find F1, so force 1, which is somewhere here, this cable, and I would do it by the magnitude. So it's magnitude, and then the cosine, so let's put this in parentheses, the cosine of the angle, which is 150 degrees, and then its horizontal component, and then plus the sine of 150 degrees and its vertical J component. All right, so of course, how much further can I go? Not too much further. So of course, if I put all the pieces that I know in here, the cosine of 150 degrees is negative square roots of 3 over 2. And then the sine of 150 is 1/2. And so I have that piece. All right, moving right along. If I do force 2, the blue kind of squeaks. I don't know if you can hear that. And so this is this cable, so I'm looking of course at the 45 degrees, so I get the magnitude, and then looking back up there I get the cosine, 45 degrees in this case, and then sine 45 degrees. And so of course this would equal the square root of 2 over 2, and then the square root of 2 over 2. All right, so far, so kind of good. And then force 3, well, that's given, that's my box, but notice that it's negative, so it would be in the negative vertical 1200 J. Now from here, what you want to do is you want to put everything with the I component together. So I, and then you're going to want to put everything with the J component together. J, that's a horrible looking J, but it is a J. So let's do that. So I'm definitely going to run out of board, but to get you started, the I component, is I'm going to take my negative, so let's do that, negative square root of 3 over 2, so you can see that's the first I there, and then with force 1, and then I'm going to add the next one, which is right here, so square root of 2 over 2 with force 2. All right, and it says they're at equilibrium when this equals 0. So I set it equal to 0. Then I do the same thing with the j's. So the j component is looking up here. I see I have a, oops, I'm getting too close there, a 1/2. And then I see I have, once again, square root of 2 over 2. But then don't forget, the last piece is I have to put in this one, which is minus 1200, and I set that equal to 0. Now, a lot of times students they just don't like all of these magnitudes and the way everything is written out with all these arrows and all this. So what you might do is, just set these as variables. So -3 over the negative square root of 3 over 2x plus square root of 2 over 2y equals 0. And then so ultimately what you're going to do is in the I component, you want to solve for force 2, okay? And then when you solve you get it in terms of force 2, you're going to plug that into the j component. And so your j component will have just force 1. You can solve for force 1, and then you back solve. It's just a lot of algebra, okay? But this is to get you started on it. And then, like I said, if it's easier, just make this x, that y, and then go through and do your whole algebra thing where you solve this one for y, you plug in what you solve, and you solve the other one for x. So back solving. Let's get them algebra skills down. You can do it.